Hello everyone, welcome to Memoneet. I am Aprajita, your chemistry SME, and I welcome you all to another amazing video lecture on the next topic. So first of all, tell me how are you all doing? I hope everyone is doing good and your BPT 3 went well. Right, so I hope you people have attempted the questions there and you have watched the video solutions also. If not yet, please go and watch the video solutions of BPT 3. And if you are having any issue in any of the question, you are not able to understand anything, do let me know in the comment section, so I will try to clear all your doubts. Okay, but you people have to let me know in the comment section if you have faced any doubts from the first two chapters that we have covered in BPT 1, 2 and 3. Okay, so today we are back with another amazing lecture. As you can see here, we are going to start with the topics for the Bhramastra part test 4. So let me tell you a little bit about Bhramastra part test 4, that what is going to be the syllabus and when it is going to happen. So let me show you class. So here you can see students that the BPT 4 is going to be held on 23rd of June. Okay, and the two chapters that we have taken in chemistry are structure of atom and chemical bonding and molecular structure. So basically these are your basic chapters. We are starting with basic chapters plus the chapters that have good weightage. So these two chapters are your basics also, plus they carry actually a very good weightage in Neet examination. So we are going to cover these two chapters for chemistry. Okay, the structure of atom and chemical bonding and molecular structure. Okay, so I will be starting with the chapter 1, that is the structure of atom. All right, so that's what our today's topic is. So students, I have divided this chapter into 3 lectures. Okay, so I'll be posting 3 video lectures for this chapter, structure of atom. The reason is, see, I can cover it in one whole like video lecture also, but that's what I don't want. So I want you people to revise the things slowly along with reading the NCRTs and solving the PYQs and various questions. So I'll be dividing it into 3 short videos around 30 to 40 minutes so that you can easily understand all the concepts that are there in this chapter and you can perform well. Okay, like all the basic concepts get cleared. So basically what is there in this chapter? So in this chapter you all know that we are going to talk about structure of atom, which is the basic building block of matter we have studied, right? And we have seen that in Dalton's theory, so we have studied it in some basic concepts of chemistry, that in Dalton's atomic model, actually Dalton explained us a little bit about the structure of atom, but his postulates were proven to be wrong. Now, when they were proven to be wrong, when there was the discovery of subatomic particles, because he actually said that the atom is indivisible. But later on, when scientists discovered the subatomic particles, these postulates went wrong. Alright, so in the structure of atom, so actually, Dalton's theory was able to explain the law of conservation of mass, the law of constant proportion, multiple proportion, but there were certain things that it could not explain after the discovery of subatomic particles, right? So in this session, we will be discussing various experiments that were carried out by the scientists to understand the discovery of the subatomic particles, as well as the various models that were given by the scientists to discuss the structure of atom. Okay, so then first of all we will be starting by the subatomic particles, that is the discovery of electrons. Okay, so students, to study the discovery of electron, first of all you know that electrons are the subatomic particles which have a negative charge, right? So they are having a negative charge, and how they were discovered, so for that we need to study this cathode ray tube experiment. Now various scientists try to study the behavior of these charges through this cathode ray tube. That's what we are going to study. So basically what happened is, this cathode ray tube, so this setup that we are having along with us, it is a cathode ray tube. Okay, so this cathode ray tube is made up of glass which is having two thin pieces of metal, right? And those thin pieces of metal are called electrodes. So can you see here, these are the two thin pieces of metals which we call as electrodes. Okay, the one having a negative charge is called a cathode, and one having a positive charge is known as the anode. Okay, so we have attached it to vacuum, and different gases are like pumped here, all right, in this cathode ray tube, and their behavior is studied when a high voltage current is applied here. All right, so that's what we are going to do, because see, it is connected to a high voltage source. So this is what our cathode ray tube setup is. All right. So students, when the current starts flowing here, actually we are applying a high voltage current. Okay. So that's important, that whenever a high voltage current starts flowing here, so like when we apply high voltage in this case, so current starts flowing here through a stream of particles, and those stream of particles we can see they are moving from the negative electrode, which means the cathode, towards the positive electrode, which is your anode. Okay, so that's what we call as the cathode rays. So these stream of particles, these are known as the cathode rays, and these cathode rays can be studied by making a hole in the anode. Okay, so when we make a hole in this anode and we are coating this area with some fluorescent material, like we are taking zinc sulfide. Okay, so what happens in this case is, when we are taking some fluorescent material and we are making a hole in the anode, cathode ray passes through it and they strike this screen of zinc sulfide that we have taken, and it produces fluorescence. Okay, so that will let us know that yes, some rays are being produced, because these rays we cannot see, right? We can actually observe the fluorescence. So fluorescence can be observed by coating it with some fluorescent material, like here we have coated it with zinc sulfide. So these rays actually, they were coming out from the cathode and they were going towards the anode. Now, what were the characteristic of these rays? That's what we need to see. So students, what actually happening is here, that these cathode rays, they are traveling from the cathode towards the anode. I told you they are themselves not visible, but they will be like their behavior can be studied by using some fluorescent or some phosphorescent material. Apart from that, these rays, they travel straight in the absence of any magnetic or electric field. But if any electric or magnetic field is applied, these rays behaved in such a way such that the negative charged particles or the negatively charged particles would behave. So that let us know that these cathode rays have negatively charged particles, which were named as electrons. So this is how these cathode rays actually led to the discovery of electrons. Okay, because they are consisting of negatively charged particles. Now the next thing is, students, that these cathode rays, this is a very important point, that their nature does not depend on the material of the electrode or the gas present inside it. Okay, so they are not dependent on that. So that tells us that electrons are the basic constituents of all the atoms. So their nature actually does not depend on what kind of a cathode or electrode you are taking, or what kind of a gas is present inside your cathode ray tube. Okay, so that's what how, or you can say that's how the discovery of electron took place. All right, so students, these rays were discovered, and if we got to know that yeah, there is these rays consist of negatively charged particles, which we called as electrons. So there was a scientist whose name was J.J. Thomson. You might have heard it many times. He tried to find out the charge to mass ratio. Okay, so he tried to find out the charge, which is E, to mass ratio, which is Me. Me means mass of electrons, charge to mass ratio for these particles, right? Now what he did actually, he applied electric field and he applied magnetic field perpendicular to each other as well as to the direction of the cathode rays. Okay, and then he studied the deviation. I told you that whenever there will be an electric or a magnetic field applied in the path of these cathode rays, as these are negatively charged particles, right? So they will be influenced by your electric or magnetic field. So he actually argued that these deviations, okay, actually it depend on the magnitude of charge. Okay, first point is it depend on the magnitude of charge of these rays, means greater the charge, greater will be the deflection. Okay, means if the charge of these rays is more, the deflection would be more. Then he said that it is going to depend on the mass of the particle. Okay, and he argued that lighter the particle, greater would be the deflection. So if the particle is light, the deflection would be more. Okay, and moreover it also increases, means the deviation will increase with the magnitude of electric and magnetic field. Okay, means if the electric and magnetic field is stronger, so definitely the deviation is going to be more, right? So that's what J.J. Thomson argued. Now can you see here, students, that this setup, it is actually showing you, see the magnets are there, you can see the electric field, this is the positive plate, this is the negative plate. So what happened is when only electric field is applied, okay, just note here that when only electric field is applied, so what happens is that the rays will deviate towards point A. Okay, and when only magnetic field is applied, they will deviate towards point C. Sorry, not B but C. Now why it is so, you know why it is deviating towards point A, because this is the positive plate of the electric field. Okay, and you know that these rays are negatively charged, so negative will get attracted towards the positive plate only now. And when only magnetic field is applied, it goes towards the. But by balancing the electric and the magnetic field, we can again bring back the cathode rays to their original position, which is B. Okay, means when the balanced field is applied, so it will go to point B. So by studying these deviations, actually Thomson found out the charge to mass ratio. Now what was that? So by carrying out the calculations of the deviations to the amount of electric and magnetic field, the charge to mass ratio, he actually calculated it to be 1.758826 into 10 to the power 11 coulomb per kg. Okay, so where the charge is measured in coulomb and mass is measured in kg. Now students, the charge on electron, it was actually determined by Millikan's oil drop experiment. Okay, so by Millikan's oil drop experiment, the charge on an electron was found to be minus 1.6 into 10 to the power minus 19 coulomb. So this is the magnitude. Minus sign is because electrons are negatively charged particles. Okay, so by using this charge on electron, which was determined by the Millikan's oil drop experiment, we can find out the mass, right? So the mass of the electron could be found out by dividing these values, that is by the charge. So here it will come out to be 9.1094 into 10 to the power minus 31 kg. So this is the mass of an electron. So see, this is how the electrons were discovered. The first discovery of any subatomic particle that was made was the electrons, where we had this cathode ray tube experiment. Then charge to mass ratio was found out by J.J. Thomson. Then Millikan's oil drop experiment was done. So it was just not done in one go. There were different things that happened. Okay. Now if I talk about the discovery of other subatomic particles, that is your protons and the neutrons. So let's see that. So electrons were our negatively charged particles, right? Now if I talk about the discovery of protons, so there was a scientist whose name was E. Goldstein. Okay, now what did he observe? He actually observed, students, that in the case of this cathode ray tube experiment, he found out that in addition to your cathode rays, there exists some positively charged rays as well. Now, what does that mean? Here you can see the setup. So actually, he repeated the same discharge tube experiment, okay, with a cathode, anode, high voltage applied. But instead of the cathode, he actually used a perforated cathode. Perforated cathode means having some tiny holes in it, okay. So yes, when you apply a high voltage, obviously cathode rays would be observed, as we have studied earlier, right? Cathode rays which are moving out from the cathode and towards the anode they are going, right? These rays are the cathode rays. But Goldstein actually observed that not only cathode rays were produced, but a new type of rays were also produced simultaneously, which were moving towards from the anode and moving towards the cathode, and they actually passed from these tiny holes, okay. So these rays were actually named as canal rays or the anode rays. Now you know canal rays because these are passing from the canals. Canals means these tiny holes that we are having, all right. And these rays are originating from the anode, so that's why we call them as canal rays or the anode rays. Now what were the characteristics? Now I told you that the characteristics of cathode rays did not depend on the nature of the electrode or the gas used, but in the case of canal rays or your anode rays, it actually depended, the characteristic of these rays actually depended on the nature of gas used, okay. And they are actually the positively charged gaseous ions, okay. So automatically they are going to depend on the nature of the gas, right? They are positively charged gaseous ions. And it was studied that the behavior of these rays in presence of electric and magnetic field was opposite to that of the cathode rays. It means that if cathode rays are made up of negatively charged particles, these rays are made up of positively charged particles, which were later named as protons. Okay, so this is how the positive charge particle or the protons were discovered. Then if I talk about the neutrons, so in the case of neutrons, students, they were actually discovered by James Chadwick. So again, when the discovery of electrons and protons happened, certain results were taken out and they were not coming in accordance to the observed results, right? So in that case, so actually it was observed that there must be some other particle present in the atom, as the mass of the atom was not in accordance with what was being observed, right? So actually James Chadwick, he bombarded the beryllium sheet, okay. He took a beryllium, very thin beryllium sheet, and bombarded it with alpha particle, and then he observed some particles which were carrying no charge. See, they were not having any charge, that's why their discovery took time. It was difficult to observe them because they are not having any charge, but we cannot neglect them because their mass is slightly equal or more, slightly more than that of the protons. So we cannot ignore it because the mass of the neutrons is adding up to the mass of the atom, right? So by bombarding the beryllium sheet with alpha particles, these neutral particles called neutrons were discovered. That's it. We don't have to go in detail. Okay. We have studied the cathode ray tube experiment, which was important, right? So now, students, if I talk about the characteristics of these particles, so I have a table for you. So here students, you can see that we are having these three subatomic particles, electrons, protons and neutrons. So the charge of electron is minus 1.6 into 10 to the power minus 19 coulomb, and the charge on proton is same, okay, in magnitude but opposite in sign, that is plus 1.6 into 10 to the power minus 19 coulomb, and the charge on the neutrons would be 0. Then if I talk about the relative charge, so we take the relative charges minus 1, plus 1 and 0, and mass, we have already calculated the mass for the electron, okay, it's in kg. But if you see the mass of proton and neutron, it's approximately equal, but the mass of neutron is slightly more than that of proton, okay. So 1.67262 into 10 to the power minus 27 kilograms, it's for proton, and for neutron slightly more. You can see 1.67 is same, then it's 493 into 10 to the power minus 27 kg. So it's approximately equal. If we take it in unified mass, you know what is U, right? Unified mass. So you can see the mass of electron is very less. Okay, so the approx mass that we take it is 0. Okay, why? Because the mass of electron is very less, that we neglect it when we are calculating the mass of atom. So you can see the mass of proton is 1.00727, so we take it as 1 U, and for neutron also it's 1 U, which is equal to the mass of hydrogen atom. Okay, 1 U, which is the mass of hydrogen atom. So proton and neutrons also we take the mass as 1 U. This is important. You have to keep all these things in mind. Okay, it can be asked in your NEET examination as well. The questions can be asked related to the charges and the masses as well. Okay, that's why I'm giving you this table here. Please note it. So now the thing is, we have studied the discovery of the like subatomic particles. Now when these subatomic particles were discovered, scientists were curious to know that how these particles are arranged inside the atom, right? So for that, various atomic models came up that we are going to study. So you might have studied the Thomson's model and the Rutherford's model in your lower classes. So I'm just going to revise that for you. Okay. Then the main one is our Bohr's atomic model and the quantum mechanical model that we have. So in Thomson's atomic model, students, what we are having is, you can see he actually said, Thomson said that the atom is spherical in shape. Okay, spherical in shape, in which the positive charge is uniformly distributed. You can see in this figure, like I can draw it also. So here the positive charge is uniformly distributed throughout the atom. Okay, if the positive charge is uniformly distributed, so you know that the mass will also be uniformly distributed now, because mass is because of the positive charge only. So we can say that Thomson said that the positive charge and the mass of the atom, they are uniformly distributed. And what about the electrons then? So electrons are embedded into it, right? Electrons will be embedded into it, just like a plum pudding, right? Or a watermelon, like the whole red edible portion is your positive charge and the seeds are your electron. You can like relate it to a watermelon also, right, students? So that's what Thomson's atomic model was. Like the very basic points are, he said that it's spherical in shape. Moreover, the positive charge and mass of the atom is uniformly distributed, and the negative charge means the electrons are embedded into it. Now, one more important point is, he talked about the neutrality of the atom. Neutrality of atom means, students, that he said that the atom is electrically neutral. Now, how will the atom be electrically neutral? It will be electrically neutral when the positive charge and the negative charge are equal in magnitude. Okay, so he said that the positive and the negative charges are equal in magnitude. As a result, the atom is electrically neutral. So that's what he said. Okay, so this was regarding your Thomson model. It's a very basic model. We have studied it in lower classes also, but we must know about it, that what did he talk about the structure of atom in his model. Okay, so that was regarding the Thomson's model. Okay, everyone. So now we will be talking about the next model, which is your Rutherford's model. Okay, because Thomson model, like we have studied, that it talked about the neutrality of the atom, and he said that the mass of the atom is uniformly distributed. Now let's see what Rutherford did. So you might have studied this famous alpha particle scattering experiment, right? So this is very important, because the results that were obtained from this experiment, they led to some important conclusions. So first of all, what Rutherford did, he bombarded a very thin gold foil whose thickness was like around 100 nanometer, okay, with a beam of fast moving alpha particles. So alpha particles were coming out from a radioactive source. Okay, so he has taken a radioactive source from his friend, and then he bombarded it with he bombarded the gold foil with alpha particles. Now, what are alpha particles? I hope you know they are actually helium nuclei. Okay, He2 plus means helium nuclei, which, like, when two electrons are added to it, they will yield the helium atom. Okay, and they are high energy fast moving particles. Now, according to what Thomson said, that mass of the atom is uniformly distributed, as you can see here. So alpha particles have enough energy that they can pass through this atom, but the observations would be that alpha particle would slow down, okay, and they will suffer some like slight deflections because of the positive charge, because alpha particles are also positively charged, no. So it was observed कि जो alpha particles होंगे वो slow down हो जाएंगे and छोटे छोटे हमें deflections देखने को मिलेंगी. But to our surprise, what happened is that when he bombarded the your alpha particles with the gold foil, many amazing results were obtained. And to study the deflections, he placed a circular fluorescent sheet or circular fluorescent screen around it, so that जब भी alpha particles strike होंगे, देखो यहाँ पर fluorescence हमें obtain होगी, जिससे हमें पता चल जाएगा कि yes, alpha particles are striking there. Okay, so a fluorescent screen, you can say zinc sulfide ki screen he took and he placed it around the gold foil. Okay, so this was the setup. Now up observations kya thi, like what were the observations of this experiment that we are going to see. So students, basically the first observation was कि जो most of the alpha particles थे, right, most of the alpha particles, they went undeflected, right. Undeflected means if you are having, let's say this gold atoms are there, let me draw it like this, okay. So let's say this is our thin gold foil, right, and if we are having alpha particles, so most of them passed straight through the gold foil without any deflection. Okay, that was the first observation. The second observation was that some, or you can say a few of the alpha particles, they actually deflected. Okay, deflections देखी गई, but by small angles, right? मतलब कुछ अल्फा पार्टिकल्स जो थे वो डिफ्लेक्ट हुए जाके, लेट्स से हियर इट गोस एंड इट गॉट डिफ्लेक्टेड लाइक दिस, हियर इट गोस एंड गॉट डिफ्लेक्टेड लाइक दिस. सो सम डिफ्लेक्शंस वर सीन हियर, यू कैन सी विच, और वो डिफ्लेक्शंस कैसे स्टडी करी गई, बाय प्लेसिंग दिस सर्कुलर फ्लोरोसेंट स्क्रीन, राइट. So some of the particles got deflected by small angles. And the third point is that you can say a very few means 1 in around 12,000 particles, it got deflected by a huge angle, or you can say it rebounded, means deflected by 180 degrees. मतलब जिस पाथ से गया उसने वही पाथ अपना retrace कर लिया. It retraced the path like this, it went like this, and यहीं से it went back. So it happened for very less particles, like 1 in 12,000 particles. Okay, so अब in आपकी जो ऑब्जर्वेशंस थी उससे हमें क्या पता चल रहा है, व्हाट वर द कंक्लूजन्स मेड आउट ऑफ इट. सिंस मोस्ट ऑफ द अल्फा पार्टिकल्स वेंट अनडिफ्लेक्टेड, ठीक है, अनडिफ्लेक्टेड चले गए, मतलब उनके रास्ते में कोई हिंड्रेंस नहीं है, राइट, अगर उनको कोई रोकने वाला नहीं है, दैट्स व्हाई दे वेंट स्ट्रेट ना. सो रदरफोर्ड कंक्लूडेड दैट मोस्ट ऑफ द स्पेस इनसाइड द एटम इज एम्प्टी, कि ज्यादातर जो स्पेस आपके एटम के अंदर है इट इज एम्प्टी, राइट. नाउ सम पार्टिकल्स गॉट डिफ्लेक्टेड बाय स्मॉल एंगल. सो अब वो स्मॉल एंगल से डिफ्लेक्ट कब होंगे, जब कोई एक स्ट्रॉन्ग रिपल्सिव फोर्स होगी जो उनको बाउंस बैक करा दे, राइट, विच डिफ्लेक्ट्स देम बाय सम एंगल, राइट. एंड वो जो रिपल्सिव फोर्स है वो कहाँ से आ रही है, बाय द पॉजिटिव चार्ज. सो पॉजिटिव चार्ज तो एटम में है, बट वो इतना स्ट्रॉन्ग होना चाहिए कि द पार्टिकल्स गेट डिफ्लेक्टेड. तो इट मीन्स दैट जो पॉजिटिव चार्ज है it will be concentrated in a small space, right. मतलब वो spread out नहीं है, it's concentrated in a small space only. It is not spread throughout the atom like Thomson said. Okay, this was the second. Okay everyone, so the third important point that was argued by Rutherford, he actually made some calculations and he found out कि ये जो positive charge है, it is concentrated in a very small space. Means if the atom is of the size 10 to the power minus 10 meters, so then the size of this positive charge, now this positive area he called as nucleus, right? So the size would be 10 to the power minus 15 meter, means the positive charge occupies a very little space inside the atom. It's not spread throughout, likewise Rutherford Thomson said. Okay, so जो थॉमसन मॉडल था यहाँ पर, that was proven to be wrong. Only one point is there, that yeah, atom is electrically neutral, right? So these were the amazing results of Rutherford's experiment, and based on these observations he gave us a model which we call as Rutherford's atomic model. Okay, now what did he say in his atomic model? So let me show you. So students, these are the main postulates of Rutherford's atomic model. He actually said that the positive charge and the mass of the atom was concentrated in a very small region or in a tiny volume. So he called that small region as nucleus. So you know Rutherford is given the credit of the discovery of nucleus, which was a very important discovery at that time. And he said that this positively charged nucleus is present in the center of the atom. I told you the size is around 10 to the power minus 15 meter, where the size of atom is around 10 to the power minus 10 meters. Okay, then if I talk about electrons, so he said that the nucleus is surrounded by electrons and those electrons are moving around the nucleus with a very high speed in circular paths, and those circular paths were called orbits. Can you see these black colored ones are the electrons which are revolving around the nucleus in different circular paths. Okay, now you can relate it to our solar system. सोलर सिस्टम में क्या होता है, देयर इज अ सन इन द सेंटर, प्लैनेट्स आर रिवॉल्विंग अराउंड इट. सेम गोस विद एटम, देयर इज अ न्यूक्लियस इन द सेंटर एंड द इलेक्ट्रॉन्स आर रिवॉल्विंग अराउंड इट इन देयर स्पेसिफिक ऑर्बिट्स. ओके, सो दैट्स व्हाई हम इस मॉडल को प्लैनेटरी मॉडल ऑफ एटम भी बोल सकते हैं, राइट? So it actually resembled the solar system. And then he said कि जो electrons और nucleus है, अब उनको कोई रोक के भी तो रखना चाहिए एक साथ. So they are held together by electrostatic forces of attraction. मतलब the forces that exist between positive and negative charges, those are the electrostatic forces, right? So that was Rutherford's atomic model. Although it was a great research at that time because nucleus की discovery हुई, that was very important, but again it had certain limitations to it, right? इस model में ही कुछ limitations थी. So that's what we are going to discuss now. So students, basically we are relating this model to the planetary model, right? तो planets orbit में revolve कर रहे हैं and here the electrons are revolving also in the orbit. Now what is the case in this case, that अभी अगर हम limitations की बात करें, so अगर कोई चीज एक circular path में revolve कर रही है, if a body is moving around in an orbit or in a circular path, so it gets accelerated. दिस इज अकॉर्डिंग टू योर लॉज ऑफ क्लासिकल मैकेनिक्स. देखो, अगर नॉर्मल स्पीड, लाइक अगर स्पीड कांस्टेंट भी है, अब आप बोलोगे कि मैम इफ इट इज रिवॉल्विंग विद अ कांस्टेंट स्पीड तो कैसे एक्सेलरेट होगा? बिकॉज इन अ सर्कुलर पाथ एट एवरी पॉइंट द डायरेक्शन वुड बी डिफरेंट. नो, see like this, if we draw the tangents, so at every point the direction would be different, and because of that, because of the change in velocity, the body would get accelerated. So that is going to happen in the case of electron. If electron is revolving around the nucleus in a circular path, it will get accelerated. Now according to the Maxwell theory, okay, so Maxwell's electromagnetic theory, it says that whenever we are having a charged particle, okay, and it is getting accelerated, so in this case also your charged particle is getting accelerated, no? So if a charged particle is getting accelerated, students, so it is going to emit the electromagnetic radiations. Okay, now you will say कि मैम planets के case में क्यों नहीं होता? Because planets are not charged particles. All right, so now let's come to this model. So according to the Maxwell's electromagnetic theory, if any charged particle gets accelerated, so it will continue to emit electromagnetic radiations. And अब अगर वो radiations emit कर रहा है, energy कहाँ से आ रही है? Because of the motion. So if it is emitting continuous energy, so जो उसका path है it keeps on getting shorter, मतलब जो path है इसे shrink होना शुरू हो जाएगा, right? And ultimately what will happen अगर energy radiate होती रही, so it is going to collapse into the nucleus, as you can see. Because so this is what we are calling as spiraling of accelerating electron into nucleus. Because loss of energy हो रहा है, emission जो हमारी EM radiations है they are being emitted, so because of the loss of energy the electron is going to collapse into the nucleus, right everyone? So according to calculations क्या होना चाहिए कि 10 to the power minus 8 second ही लगेगा इलेक्ट्रॉन को कोलैप्स होने में into the nucleus. But क्या ऐसा होता है? No, right? Atom is stable. If atom is stable, then only we have everything around us. Now matter is comprising of atom only. So इस model के according to atom stable ही नहीं होगा. If electrons are collapsing into the nucleus, the atom is going to be highly unstable, and that's the case, so matter won't exist. But that's not the case, because matter exists means atom stable hai. So that's the limitation of Rutherford model, that it could not explain the stability of the atom, right? So now what if we consider कि हाँ अगर electrons revolve करने में problem हो रही है, अगर electrons stationary हो तो, so electron stationary होने से क्या होगा, the electrostatic force between the nucleus and electrons will, like it will pull the electrons and you will get a miniature version of Thomson model. तो वो भी correct नहीं है. It means electrons move तो कर रहे हैं, but how they are moving we are not getting the point. In this case Rutherford could not explain that. Okay, and moreover students एक और limitation है, it did not tell about the arrangement of electrons. Okay, it just simply said कि electrons revolve around the nucleus in circular paths or orbits, but कैसे, how the electrons are being arranged, because we have so many electrons, right? क्या वो सब एक ही path में घूम रहे हैं या first उसमें कौन घूम रहा है, like it did not talk about the arrangement of electrons. So these two are the major limitations of your Rutherford's atomic model, right? I hope everybody is understanding these things. Now the next point is, we will be talking about some basic things before we study the Bohr's atomic model. So it's atomic number and mass number. So you know, actually students, this you have already studied. I'll just give you a recap of what it is. Atomic number is determined by the number of protons in an atom, and actually atomic number is equal to the number of protons, which we determine by Z. Okay, and you know that for a neutral atom the positive and negative charges equal, तो मतलब जितने protons होंगे उतने ही electrons होंगे. So the number of protons would be equal to the number of electrons. Okay, so atomic number is equal to number of protons and number of electrons. But अगर मैं atom के mass की बात करूँ, so mass depends on the protons as well as neutrons, क्योंकि अभी हमने देखा कि the mass of proton and neutron is approximately 1 U. So the mass number, which is denoted by A, it is equal to the number of protons plus the number of neutrons present in the atom. Okay, इसको हम mass number कहते हैं, which is denoted by A. All right, and so we call them as nucleons also. You will see that these are present in the nucleus, so we call them as nucleons as well. So if I want to represent any atom, so उसको हम represent करेंगे, X will be the symbol, Z is the atomic number, and A is the mass number. So this is how we are going to represent an atom. Okay, so atomic number in the subscript and mass number in the superscript. All right. So then you have also studied about isotopes and isobars. So what are isotopes? The one having same atomic number, right? Same atomic number but different mass number. This you have already studied, no students? Like we have hydrogen. So hydrogen के कितने isotopes हैं? 3. So 1 1 1 2 1 3. Protium, deuterium and tritium with mass number 1 2 and 3 respectively. So यहाँ पर फर्क कहाँ होता है? अब atomic number same है, right? 1 1 1 means तीनों में 1 1 proton है. Then why is the mass number different? It is different because they are having different number of neutrons. Neutrons में फर्क होगा, so that give rise to isotopes. But one thing you should remember कि if the number of proton is same, the number of electrons would be same. And electrons are the ones that are responsible for the chemical behavior of an atom. So all the isotopes will show similar chemical properties. Okay, although they will have different physical properties, but जो chemical properties हैं वो same होंगी. Why? Because the number of electrons are same. Okay, so we are covering very basic things, right? I am telling you each and every basic concept so that ये आपको clear हो जाए. So similar chemical properties आपके सारे isotope show करेंगे. For example, मेरे पास क्लोरीन के 2 isotope हैं, one is 35 and one is 37. तो although इनकी physical properties में फर्क होगा, but both of them will react in a similar way because the number of electrons are same, that's 17. Okay. Now if I talk about the isobars, so that will be opposite. They will be having same mass number, okay, but different atomic number. अब अगर atomic number different है class, if the atomic number is different, means they are different species, right? For example, if I talk about carbon, so 614, one isotope, एक carbon का isotope होता है ना with mass number 14, then you can say nitrogen's mass number is also 14. So ये आपके isobars हो गए. Similarly, argon mass number is 40, calcium's mass number is also 40, so that's another isobar. So these are isobars which have same mass number but different atomic number. ये आपको पता होना चाहिए because they are having they are the different chemical species. Okay. So students, in today's topic, firstly we started by talking about the subatomic particles, how they were discovered. We discussed the cathode ray tube experiment, okay, discovery of electrons, then protons, then neutrons. Then we studied their characteristics like charge and mass and all. And then after that we started by talking about the Thomson's atomic model, then Rutherford's experiment we discussed, then his model and the limitations. So that was regarding, it's actually an introduction about this chapter, right? The first lecture is about the introduction. Now in the next lecture we will see that how these like models were not very successful and what were the developments that led to the discovery of Bohr's atomic model. Like there were certain things that this model could not explain, so we required another model and that gave us the Bohr's atomic model, right? But before we leave, I want to give you one question and I want you people to answer that question in the comment box. Okay, so today you will watch this video. I will see your comments in the next lecture. Alright, so I want everybody to comment in the comment box and tell me the answer. Very basic question. It's actually a PYQ. Okay, so I am giving you a previous year question because I want you to know कि जो हमने आज पढ़ा, that is also very important and can be asked in the Neet examination as well. Okay, so let me give you the question. So students, the question is select the correct statements from the following. As you can see that this question was asked in NEET 2023 examination, okay, and it's a direct question from your NCERT. So there are 5 statements which says atoms of all elements are composed of 2 fundamental particles. Mass of electron is 9.10939 into 10 to the power minus 31 kg. All the isotopes of given element show same chemical properties. Protons and electrons are collectively called nucleons. Dalton's theory regarded the atom as ultimate particle of matter. So out of these 5 statements, you need to find out which one is the correct statement and you have to give the answer as A, B, C or D. So I'll be waiting for your answers in the comment box, alright, that which answer it would be there. So it's a very simple question from a very simple topic. You see the topic is subatomic particles. Now you know students, if you want to know, now there are a lot of topics in a particular chapter. So if you want to know that which question was asked from which topic in which year, so you have to study the PYQs, right? And it has become very like difficult for you to like segregate the questions and everything. So we have done the task easier for you. So in our NTA Memoneet's only NTA PYQ book, we have taken the questions from 2019 to 2024. Yes, the most recent one, NEET exam that happened recently. So usme you will get all the questions chapter wise milenge. and that to topic wise, like subatomic particles. Then we will see the dual nature of matter. Then we will see the quantum mechanical model. So topic wise we have segregated each and every question, and we have also given the tagging that in which year this question was asked. Along with that you will get detailed explanations also. Okay, so let me show you that. So as you can see here, these are our NTA PYQ books. So for chemistry, you can see that it's chapter wise plus topic wise, like I have told you, and it's updated like whatever Neet syllabus is there for 2025. It's totally updated. You have the crisp and detailed explanation. Moreover, if you are not able to understand any explanation, so you can just click on the QR code given with the question, and you will get a video solution for each question. Yes, we have also recorded video solution for each and every question present in the book, which you can watch and understand the question easily. So all these features you will get in our only NTA PYQ book. Okay. So I told you that you will get the NCERT reference also, means explanation के साथ you will get to know कि किस page number पे आपको ये concept मिल जाएगा. So I don't think any other book covers that, right? So that's what we have provided you, a lot of things in just one book. So please go through it. Okay, please have your copies of this NTA PYQ book. Order it as soon as possible. And yes, please answer this question in the comment box. So for today, this is it. And in the next lecture, we will be talking about the developments that lead to the Bohr's atomic model, and we will study the Bohr's atomic model in detail. Okay, so until then, students, thank you so much. Take care. Bye bye.